This is the second example from 2.3 day 2. We talked about multiplicity in the previous example, and now we're going to use multiplicity to help us graph a function by hand. So what I wanted to start with here is, before we get to the example, what are we doing in this process to get there? So I've got a little list going that you can cross-reference here as we go along. Step 1 is going to be find the zeros. So we're going to have functions that are in factored form. We're going to find the zeros first. We are going to determine if the zero is one where the graph crosses or bounces. That's based on the multiplicity, and that's really the main point of this example, is to determine how that works. Once we do that, once we graph those zeros, see if they cross or bounce, then we're going to find a few points between the zeros to estimate where the graph is going. Now, this is going to be an estimate of the graph. It's not going to be perfect, but it's going to be as close as we can get, with the information we have. If we want better estimates, all we have to do is just make more points, and so that's something that you'll be able to see as we go along here. So we'll start off with looking at the example, and step 1 is to find the zeros. Now, since it's already factored, that's a pretty simple part of the process here, because we know that whatever makes this 0 is going to be a 0. So we have x minus 2, that one is going to be just a 0 of 2. X plus 2 is going to be a 0 of negative 2. And so what we're going to do with that, first of all, is we're going to plot those just as x-intercepts on our graph. So here's at negative 2, and here's at positive 2. So that's step 1 in this process. Now, what I kind of like to do with this, when I have those zeros, and this will make more sense after we really start getting into this graph, is I like to kind of make those as my vertical boundaries for this graph. So I'm going to draw in this really faint red line right now, just so that we have a little bit of a boundary to think about. And we're going to use this as far as selecting points, so that it'll make more sense when we start selecting points. But notice what that does is it creates 3 different sections to the graph: a left, middle, and right. My goal in this is going to be to get just a couple other points for this graph, but have at least one in each section of the graph. And so I've got to be careful about how I choose those points. And to start with, I'll just go back to the multiplicity thing and say, all right, if we have this 2 right here, that was an even multiplicity. So what we know about that one is that it is going to bounce because it's even multiplicity. Here is an odd multiplicity, the negative 2, so that one is going to cross the x-axis, and that's going to be helpful once we get our other points and just to get a general idea of the shape of that graph. So before we, I guess at the end we're going to be checking it with a graphing calculator, but for now, let's pick some points, the easiest points we can think of. I think in the middle here, in this middle section, I think 0 is a really easy point. I always like using 0 if I can. So I'm going to put that in the middle. 0 is my x. Now if I plug in 0 for x, what's going to happen? I put in right here and here. That's going to give me 0 minus 2, which is negative 2. Square it is 4, and then times 0 plus 2. So that's going to be 8 in this case. I plug 0 in, I get 8 from this function. And so I go up here and I have a point right there as 8. Now, other points that are going to be helpful here, I kind of like to go over this side and just pick the easiest point available. So since we're at positive 2 right here, I'm going to pick positive 3 as my other x value and get an idea of what that x value will be. So if I plug positive 3 in there, that's 3 minus 2, so that's 1 squared, that's just 1, times 3 plus 2, or 3 plus 2 in this case, so it's just 1 times 5. That means that my point is going to be 3, 5, and so I can put that right up here. 1, 2, 3, oops. 1, 2, 3, 4, 5. So there's my next point. That's an extra point that I have on this whole thing. And now Going the other direction, I could also choose -3. Now this one's going to be a little out of hand because we're going to have -3 minus 2, that's -5 squared, so that's going to be 25 times -3 plus 2, that's -1, so multiply those together, I get -25. So that means that -25 is right here. Now that's way off my grid, but we know that it's really straight down in this case. So my last step of this process is going to be to try to sketch this thing using the points I have. I don't have a whole lot, but I do know that this one bounces, and so I see that I've got a point up here, it's supposed to bounce, and so what I'm going to do when I sketch this graph is I'm going to make sure that bounces, and it looks like I've got to go up here back through this point, and then it's got to go through here and cross, and so I'm going to go sharp back down again. And again, keep in mind this is a sketch, and then this one's going really fast downward. And so I've got a graph that's not going to be perfect, but at least it's maybe something like the real graph. So as my last step in this problem, I'm just going to check it. I have it entered into my y equals. I'm going to graph it on my grid, and I'll notice that it does look something like what I have here. I might go through and check a couple of points just to make sure. But if I wanted to get it more accurate, I could just choose more points. That would simply mean I'm going to have a few more items in my XY table. But use the multiplicity to find if it crosses or bounces. Then we're just choosing some points in between and connecting the dots as best we can. That's how we can use multiplicity to graph by hand.